Web Summit Vancouver. Are we excited to talk about retrieval augmented generation?
Yeah.
Come on, we have the co-author of the seminal RAG paper. Are we excited to talk about RAG? Okay.
That's amazing, man.
All right, so take us back to 2020. Let's go all the way back. You're writing the paper with 7 other co-authors.
Mm-hmm.
How did it feel at the time? Did you know what you were helping pioneer?
No, I always say if we had known that, we probably would have come up with a better name than RAG. Right? The story of the paper is really we were looking for a way to make these generative models. They weren't really called language models at the time yet, to get them to work on data that you could swap out without needing to retrain on the data. And so my PhD was in grounding and making sure that you could understand language with respect to something else. And we were like, what if you understand language with respect to Wikipedia? And then you just swap it out. So I was working on that with a student, and he had to go back to school. So we found some other collaborators, and that led to something really amazing in hindsight. I don't think we realized that at the time, no.
Okay, so today we're going to talk about RAG, what it is. We're going to talk about where it's going, and also why some people believe it's not going anywhere. So give us the layman's version of what is RAG, very succinctly.
Sure. So it's 3 letters, right? R, A, and G. And so the G is just a generative model. So that's the language model that generates words in sequence. Then you want to augment, that's the A, that language model with information that it hasn't been trained on. And the way you do that is using the R, retrieval, search. So basically, you have a bunch of data, you search relevant pieces of evidence, of information in that data, you give it to the language model as context. And that's really what RAG is. It's a very simple idea.
Okay, and why are some people calling for its demise? Why do they think it's inevitably not going to matter anymore?
Yeah, so I think because it's such a simple idea, some people are kind of confused about what RAG really is. And over the years, I think, so it's 5 years old. We celebrated the 5-year anniversary last week, so very recent. Initially, it was just a vector database with a language model. So that was kind of a silly idea. And then over time, this became this very complicated system with much more things going on, right? So modern RAG is very different from what we did in the original paper, actually, but it's still called RAG. So I think some people think that with like longer context, RAG might go away, or with MCP, RAG might go away, or that you might as well just fine-tune and then you don't need RAG. So there's all these kind of dichotomies around RAG, and usually when that happens with the technology, that means that the technology is never going away, right? So if you keep getting proclaimed dead, then that usually says something about the technology, because people then like to market against an incumbent, right? It's like when Rust came out, people were like, oh, this is going to kill C++. So I think a similar thing is happening with RAG.
Yeah, I mean, phones were supposed to kill PCs, right? And we still use both.
Mm-hmm.
Why don't you tell us, give the steelman's argument. So RAG is dead. We're 5 years from now, RAG has died. What is the most likely scenario? Like, what do you think actually happened? Look at the arguments that people are giving against RAG, and tell us, what do you think? Where's the validity there?
Yeah, so if RAG were to actually die, that would mean that we would not augment our generators with retrieval.
Or it's not necessary. That's kind of what they're arguing, right?
But so you are still doing retrieval in a way, I think, if you have a very long context window, right? So maybe that's the one that comes up the most, long context models. And one way I always like to explain why that's not a very good idea is because you have to read the entire context then in order to find an answer, which is extremely wasteful, right? So if you want to, my example is always Harry Potter, right? What's the name of the headmaster in Harry Potter? It's Dumbledore. So did you have to read all 7 books in order to get the answer to that question? That's super wasteful, right? So what you want to do is find the relevant pieces that talk about headmasters, and then say, oh, the answer is
Well, but the
Dumbledore.
headmaster changed at one point.
Yeah,
So you do have to read all 7 to know that.
So no, you have to search. You have to search all 7 to know that.
Right.
Right? Not read all of them.
Yeah,
You have
yeah,
to search all
yeah.
7, and then you use the metadata, which gives you the recency to know which one is the right answer. So that's actually what RAG is designed to solve, which is much harder to do with long context, I think.
Right. Could you talk about all the variations of RAG and the different techniques now? Because RAG is, like you said, there's modern RAG now. We can talk about agents, of course. We'll talk about that in a little bit.
Mm-hmm.
But just talk about which techniques are you most interested in? What developments have you seen? What are you most excited about? What do you think is not really interesting? Or let's start there, and then we'll talk about what's not interesting.
Yeah, so I'm very interested in agents, obviously. I always say that agents are simultaneously the most overhyped thing and also the most underhyped thing. Because if agents really work, it's going to be amazing. But currently they don't work. So anybody who's telling you that agents are like ready to go, don't believe them. But it's coming soon. And so one of the interesting things that you can do with these agents is make them work on top of your data. And then the way you do that is with RAG. And the way you probably want to have the agent talk to the underlying RAG pipeline is through MCP, right? The protocol that you've probably all been hearing about. So
yeah, Anthropics, yeah.
Yeah, so all of these pieces where you have all these dichotomies where people say RAG is dead because we now have MCP, or RAG is dead because we now have long context, that all just comes together. And you should be doing all of those things. And that's really what I'm very excited about. It's just how can you take all these parts and actually use them to solve real problems. And with agents, the problem space just becomes much, much bigger because you can keep retrying if you don't find the relevant piece of information, or you can use some tool to get some new piece of information from your initial retrieval and then do some other retrieval step. So it's much more dynamic.
And so what parts of RAG, or variations or techniques that people have come up with in relation to RAG, do you think are overhyped or not really worth spending time on?
So the one where I'm a little bit skeptical still is graph RAG. So that's one of the sort of techniques that's been hyped up a lot recently, I think. I haven't actually seen that really work yet.
Okay.
In the naive version, that's just a data augmentation strategy. So you take some hierarchical information from a document and you put it in the vector database. I don't think you need a full like graph database or all kinds of like fancy things. But graphs are very complicated, and people like working on complicated things sometimes.
So do you think they're wasting their time?
For now, I haven't seen any evidence that they're not.
Okay. Could you talk a little bit about where you want RAG to go? Like if you owned it, if you will, or if you could give it a specific direction, where do you want it to go?
Yeah. So the original RAG paper, when we wrote it, it was about how can you jointly optimize all of these components. So you have this retriever and this generator, and how can I now make sure that they actually work together and that they're really working in lockstep? And then what ended up happening because of in-context learning is that you could just have a language model, give it the evidence, and you don't actually need to train the retriever to work together with the generator. So you get these Frankenstein solutions. The original RAG paper is actually saying, if you backprop into the retriever, and we talk about different ways that you can do that, and that retriever trains jointly with the generator, then you get much better performance than these Frankenstein systems. So the Frankenstein is a baseline in table 6 of the paper, and that's what everybody's using now. So what I would like to see is a lot more systems level thinking about RAG systems, and thinking like I have all these components, and like a modern RAG system can have like 12 different model components. How do I make sure that they all work together, and how do I use machine learning to jointly optimize those components?
Do you have any regrets? Like if you could go back when you were writing it, would you change anything?
Yeah, well, the name is one thing, obviously.
Sure.
Yeah, I think it was just right place at the right time, right? So we get a lot of credit now for something that is mostly other people's work, actually. So
yeah.
Phase, the vector database, it's the Facebook AI image search library, and so that was the first vector database that was there. DPR was a way to encode embeddings. BART was the language model, encoder, decoder, generative model, and we basically just stitched those things together and then showed that you can backprop into the retriever. I don't think without any of those components we could have done that.
Do you think that RAG is going to just be around forever, or do you think that it's going to have to evolve to continue to stay relevant?
Yeah, so I think that really depends on how you define RAG, right? So in my definition of RAG, which is just retrieval augmented generation as it literally what it says, which is I have a generator and I augment it with some retrieval capabilities. I think as long as Gen AI is here, and so I think it's here to stay, then you will want to augment these models with some form of retrieval. So I don't think that that's going away. But maybe vector databases might go away at some point, or at least they're already kind of getting replaced by maybe more traditional databases that also have vector capabilities, right? RAG 5 years from now will look very different, but the concept will still be there.
Is there anything that keeps you up at night in relation to RAG? Like, what are you most worried about?
Not around RAG. I'm more worried about other things. Sort of, I'm worried about hype cycles. I'm worried about a lot of people talking. So yesterday we were on this panel about AGI, and a lot of people are obsessed with AGI, and I'm much more interested in actually getting this technology to work. I'm worried about companies not aiming high enough and sort of settling for the simple problems while this technology is very powerful, but you need to know how to do the change management in order to really get this stuff to work in your organization. So I worry about very different things. So honestly, I don't care if RAG doesn't exist in 5 years. That's fine by me. I care much more about whether AI is actually getting used.
Okay, but your company, we should talk about your company a little bit. It does depend on RAG succeeding, does it not?
I don't think so. We're called Contextual AI, and I think if I could go back in time, what I would call RAG is probably something about contextual.
Okay.
I think it's a good word to capture sort of what really the essence is, which is that you want to contextualize generative models with the information they need to do their jobs. Right? So if I have some Gen AI problem and I want to solve it, I need to make sure that that language model has the right context. And that's really the fundamental problem to solve. And I think actually if you look at the trends that exist now with language models, and we've seen this with DeepSeek, for example, is that language models are actually becoming commodities, right? It's rapidly commoditizing. So that means that all language models are pretty much good enough right now to do lots of interesting tasks, as long as you give them the right context. So that's really the hard problem to solve. I think RAG is just kind of, that's basically what RAG is about, is making sure that you retrieve the right context so that you can have the language model succeed. But if that gets replaced by something else, then that's fine by me, as long as we provide the context.
So contextual retrieval generation or something?
Yeah, maybe.
I guess it doesn't flow as nicely as RAG, right?
Exactly, yeah. Doesn't have a nice acronym with it, yeah.
So if you could change your company to something that is unrelated to RAG, where would you take it?
Yeah, probably in the direction of agents. I honestly think that a lot of people are seriously underestimating the extent to which agents are going to change everything. And so maybe I shouldn't even say agents.
Yeah, let's define agents, because just like AGI, just like everyone has a different definition.
One of those words. Like let's maybe not even talk about that. We could talk about test time compute.
Okay.
Right? So basically, we've seen that training is important, but and you can throw lots of compute at that, and then you get better. But during test time, if you don't care too much about latency, then you can also throw lots of compute at the problem during test time. And the abilities that you get from using that compute to reason actively over the problem that you're trying to solve, that just unlocks so many problems. It's really, I think that was really the missing piece, honestly, to getting AI to be really useful. So this is really going to change everything.
And you believe that people are not focused on this enough? People are distracted by other things?
Yeah, so I think a lot of people don't really understand where this can go. It's basically because the current sort of rudimentary prototypes, if you look at sort of O1 or O3 or like even DeepSeek, like it's kind of a cute gimmick and it can do some math and it can maybe do some coding. But in the long run, when you equip this with all kinds of different tools and it can just plug directly into all of your different systems and do interesting things, that is extremely powerful. And so right now, it reminds me a lot actually of the early days of RAG, where everything was still very brittle. Everybody was complaining, like these models hallucinate, and now with test time compute, they hallucinate more. But we've seen that over time, we know how to fix these problems. So in the next couple of years, this brittleness is going to go away, and then this is going to, I think Dario, the Anthropic CEO, said this a couple of days ago. It's going to change a lot of white-collar jobs forever, and maybe make those jobs go away. So I think people need to take this very seriously.
Okay, so people should care less about RAG and they should care more about agents.
They should care about RAG agents, I think. So agents that work on your data, and that's what RAG agents are.
Could you, let's say you didn't have that at all, could you in theory, like do you see a world where companies are just training models based on their own data from scratch? Like let's say compute gets really, really cheap and they're just doing that and therefore they don't need RAG and they don't need grounding because what they're doing is creating very tiny models. Is that a possibility?
At the surface, that sounds like a decent idea, right? Like why not do that? But the problem is that what you're doing with that type of fine-tuning, what you're describing, is you're taking a base model that has been pre-trained.
But what if you're not taking a base model? Like what if you could train a model, but is it possible that we'll get to really, really cheap
Right, so you're
models?
saying we'll train completely new base models from scratch every single time we have like new data. So basically every day.
Well, let's say you're trained on only your company's data and, I don't know, Wikipedia or some sort of training data set plus your company's data, and then sure, you retrain if there's like a major update and a new version of an internal document or something.
Yeah, so maybe theoretically that's possible, but not.
But it's just too expensive right now.
No, so it's not about expensive. It's about you need lots of parameters for these models to be good.
Right.
And so in order to actually train these parameters, you need lots of data. And to pump all that data through these parameters and train them,
a completely different,
you need lots of compute.
Different approach to training. Like
yeah.
the way we train is...
Let's say we don't have transformers anymore, we don't rely on GPUs, and we solve the scaling laws where we can do this with very small scale and still have it work, then sure. But I don't think any of those assumptions are true.
Okay.
So that's basically what training scaling laws are about, right? Is saying you need to have a certain scale for it to actually be able to generalize.
Right. Okay, so that's why you created the domain isragdeadyet.com, and you don't think it's going to die because you're always going to need to go back and refer to the latest data that you want to keep in context.
Yeah. So the fine tuning versus RAG, that's another one of those dichotomies. But I think on the fine tuning one, there's another point where if you take the base model and then you fine tune the base model, you're not actually putting new knowledge into the base model because that has been trained on trillions of tokens and you have your company's data, maybe a few million tokens. If you fine tune on that, you're basically just eliciting certain behaviors in the base model, and that's what the fine tuning does. You're not actually putting new information into it because you don't have enough data to do that.
Yeah.
So the real way to solve real problems in the world is to take all of these different parts. You have RAG. You want to retrieve lots of information. You want to put that in the context of a long context model, ideally, so that you can put lots of information in there. Then you want to fine-tune as many of those components as you can, ideally together. Then you want to put MCP on top so that it can plug into your agent. All of these things, they work together. So that's why RAG will never die.
Perfect. Let's end it there. I mean, I can talk about this all day, but yeah, we're way over time, and they're already mad at me backstage.
Okay.
So
I'm sorry.
thank you so much.
Thank you.